Welcome, everyone. We are here for day 3 of the Enterprise Architect Bootcamp, and I'm real excited to be back. And today we have more fun things to cover. We're going to be covering architectural guardrails, setting them up, principles, standards, and patterns, and making sure we avoid architectural anti-patterns. And we'll talk about what goes into that, creating principles, creating strong principles, creating real standards and guidelines. So a lot to be said on that. We're going to talk more about reference architecture patterns and scaling decisions. We talked about them in the last session, but we're going to talk about them a lot more. And we're going to be talking about the purpose of them and how and when to standardize and how to communicate these reference architectures and then get people to follow them and adopt them. So how to distribute them and market at them as such. So we're going to talk about some of those, key things for the enterprise architect. And then ultimately we're going to have fun where we're going to the last section of the day, we'll discuss architecture trade-offs in enterprise architecture and how to make architectural decisions and how we evaluate various options and evaluate criteria. So it's going to be a lot of fun. And then after that, we'll spend about 90 minutes on an enterprise, 60 to 90 minutes on an enterprise architecture lab where we'll have lots and lots of fun. So that's the setting of today. Now, before we begin, I'd like to tell you about some free opportunities we have help you build your enterprise architect career. So tomorrow, and every Thursday for that matter, and every Monday, we run a How to Become an Architect webinar. Now, tomorrow's webinar will be focused on how to become an enterprise architect. We'll talk about exactly what we do, exactly the skills that you need, exactly what hiring managers are looking for, what belongs in your enterprise architect portfolio, what certifications you should get, and everything about how to stand out and more. And these webinars are free. They're live on Zoom, so you can ask me any questions you want. And we'll do anything we can to help you build your enterprise architect career or other architect career on these free webinars. And we run them each week for everything. So we have that tomorrow. And on the last week of this, which is next week, we're going to be releasing a free book on enterprise architecture fundamentals to help you. It's going to go along and correspond with this course. If you watch the videos again, it'll be a set of notes, it'll be a book, lots of charts and graphics to really help you maximize your enterprise architect career. And it's free. So my team will drop that in the chat box as well as the description. So please make sure you sign up for that. Tell me where you're from in the chat box. Give me your geography. Love to know where you're at. I'm in South Florida today, and it is nice and hot, about 35 degrees centigrade, about 96 degrees Fahrenheit, super sunny, super hot. Where are you from? Tell me what it's like out there. And then we're going to get to the content. Now, I pre-recorded some of this content, so I'll be back and forth between live like I am now, and we'll play some video, and in the end, we will do all that live. So, Chris, let's begin the content for the day. Everybody, please give me a hashtag Enterprise Architect in the chat box. We'll begin the content, and then I'll see you in a bit to answer some questions. Give me that hashtag Enterprise Architect, and Chris, let's talk about guardrails. And I promise you, this is not going to be an enterprise paperwork discussion. Here's the truth that separates the really senior architects from everyone else. We architects don't scale by creating more designs. We scale by creating guardrails. Because if your architecture team needs to approve every single decision, you and your architecture team have become a bottleneck. But if teams can make consistent decisions without you in the room, based upon things that your architecture team would support, well, you've scaled your architecture capabilities dramatically and the change that you can actually make. So today we're going to focus on the 3 things that really make architecture real in an enterprise. We're going to discuss principles, we're going to discuss standards, and we're going to discuss anti-patterns. And by the end of this hour, you will know how to write a principle and a standard, and a real standard that will drive a change in behavior. Not just a slogan, not just a template that you filled out, but guardrails that teams will use because it's going to make their lives better. So let's start with the basics. What is an architecture principle? As for a basic definition, a principle is a rule that drives consistent decisions. So a principle is not going to be a tool choice. It's not going to be used as cloud service. It's going to be a rule that shapes decision making. So if we look at principles, good principles are enduring over time. Even as technology changes, they're going to be broad enough to cover many things across many teams, but they're going to be specific enough to guide choices. So a principle is going to sit between a strategy statement like be more digital and a detailed decision like use this specific service with this configuration. So if you really think about it, a principle is about translating strategy into some kind of consistent architectural behavior that we're coming up with. So I'll give you a few examples, kind of keep it real so you can better understand this. We could have, say, integration principles, which would be how systems should connect. We could have security principles, which is how risk is handled, say, by default. We could have data principles regarding, what is the truth? What is the source of truth of the data? Who owns the data? What have you? Those types of things. We can even have platform principles. When to build shared, for example, versus something else. So the question I would ask you is, how many of you have seen a cloud first principle? Hey, we're cloud first. Now that's ridiculous. How about a surgeon that says surgery first? That's not a principle. So we're going to talk about making a good principle. And now we're going to talk about how to do it. So here's the thing that I want you to think. Here's the 3 filters that I would use to test a principle. And if the principle doesn't pass the test, it's a declaration, not a principle. So the first thing is actionable. A principle has to be actionable. And that means the principle has to change behavior. Meaning people can do things differently because the principle exists. A principle, if you think, implies a preference. We prefer to choose X over Y under these circumstances, or this is our default standard of behavior. So a bad principle would be we value innovation, but a better principle would be fairly specific. Every product line we have, we will run at least one controlled experiment per quarter on that product set. And that way we use the success or the failure of that to adjust our plans. But that's the key, that we're dealing with something that's there. So the better your vision is, and the better you're giving people guidance on what to do, the more likely it is to change behavior. So that's really what we want to talk about. So a principle has to be testable. And that's the key. Is this principle testable? And if you look at a principle and can't test it, it is not a principle. And I'll give you some examples. So APIs are our primary integration mechanism. That's testable. You can look at the integration and you can evaluate the API, whatever things are going on, say with venting or what have you. That's something we can test. And if you can't test it, we can't govern it either, because we really don't know what's going on. And if you can't govern it, it won't shape decisions in any major factor in any kind of enterprise. So we're trying to help make better decisions here. And if we've got a decision-driving principle, it's helping people make decisions under the constraints that we actually define. So here's the best test I know to evaluate a principle. If the principle didn't exist, would we make different decisions? And if the answer is no, it's not a principle, it's a marketing slogan the company has. So if we have a principle that says we're going to do a certain thing a certain way, but nobody does it, technically it's a principle. To me, it's more of a slogan. So let's talk about examples of, say, decision-driving language in principles. So, for example, we might say customer protected health information must not traverse non-approved networks. Well, that tells us exactly what we need to know there. If we've got customer and patient information, it's not going to float on the internet, for example, and because the internet would not be considered approved unless, therefore, there were other things like IPsec or whatever. So fairly specific in telling you don't use public networks. It has to stay on the private network. Or shared platforms are the default for cross-team capabilities. Or We retire services that don't meet minimum observability standards. See, these are principles of saying, look, if you've got a service that doesn't give you what you need to monitor it, get rid of it and use something else, or don't choose it in the first place. So that's forcing a decision across a guide rail, getting people to do what you really want them to do that's in the best interest of the organization. So let's talk about, how do we structure a principle? How do we make it usable? And how do we make it valuable for the user that's going to use this? So maybe we'll whiteboard this one out. Bear with me. I'll make a slide over here so we can whiteboard it out. But the first thing it needs to be fairly short. And we need a fairly short, convenient name. So maybe we'll look at what we need to put into a principle over here. So if we're going to write one out, let's think about what I want you to do. So I want you to name the principle, obviously, and make it easy. So a short, memorable name. That's something we definitely need. Now, we typically will have a statement, which is a one-sentence rule, and we've gone through some of them. So there's a statement. And we keep that to one sentence. Then, the rationale, which is why are we doing this? Why it matters. And what are the implications of this? So, if we think in a context of business, implications of something, well, what do we need to do now? Or what do we need to stop doing? So, what do we do now? Or maybe stop doing. And you see, these are quick, they're to the point, because we're not trying to make it that hard. What we're trying to do is make it make sense. So if we were to come up with a principle fairly quickly, and maybe we'll do one in real time, let's come up with another one, we'll put it in a blue text box. If we came up with a statement that says, let's say APIs and we call it API primary or API primary, or whatever we name it, or something like that. And then we can create primary integration. Let's call it that. And then we can say for this statement, APIs are the default mechanism to connect system to system. And then we'll put some guardrails in there. Unless latency, for example, or resilience requirements require something else. Demand another option. Now that's the key is for it. And what are we really saying with? We're saying, look, if you want to connect system to system, you have to use the API. And if there's a reason not to, it's no longer the exception. It's now an exception, and that probably needs to go through some architectural approval. But if it's just an API for system to system, we're now inside of our guardrails, which is what we're trying to do. So that's what we're trying to do. So we're using these to make better decisions, to basically enable our teams to say, well, if we've got a system and we're going to connect API to API, that's part of a pattern we're supposed to do. Well, we know to do this. And these are the approved patterns, so let's use that so we get it done faster. That's really what we're talking about with principles. Now let's talk about standards from an enterprise architecture perspective. What is a standard? A standard is going to be a specific, repeatable way of doing something, whether that's technology choices, whether it's naming conventions, whether it's an integration pattern, a security baseline, even a CI/CD pipeline. It's a specific, repeatable way of doing things again and again. And the point of creating a standard is to reduce decision fatigue, because we've got paved roads, essentially, if you will, increase the speed we do things, and improve quality and safety all at the same time. So the mindset that I consider is standards are like paved roads. And if you view the standard as the fast lane, and you can view it that way as, if you follow the standard, life is easier because documentation already exists, Pipelines already exist. Support already exists. So follow what's already there when you can. And I always viewed when we don't have a standard, it's kind of like a gravel road. Look, you can go past it. It's possible, but it needs a whole lot more work to get through it. So if you don't have a standard, it's like that gravel road that everything needs a lot more justification, more ownership, and it requires much more effort. And that way, when we have standards, it's a wonderful thing. But if things are exceptions, we obviously may not have standards for them. So when we standardize, we go faster. And we don't standardize to restrict your fun. We standardize to enable speed. And speed and agility in business is absolutely critical, especially as markets change. So what makes security standards enable speed? Well, the first thing is standards need to be very concrete. Everyone needs to know what that standard means in practical terms. And it's not something like use security logging. It's use this logging pattern with these fields, this retention policy, and this alert threshold. And the key here is most standards fail because they don't come with the whatever support's necessary. They become theater and extra documents that don't need to exist. But support can be significant. There could be some supported standards and supported configurations, if you will, where there's tooling and automation that's already ready. There's templates that are ready to go. There's refless implementations that are ready to go. And policies that enable you to take advantage of that paved road approach when we've got a really good standard. And that really enables speed. Software repos, for example, that a company might host might be another type of an example of that. And what you want to do is you want to make a standard, and you want to make sure the teams can actually use it. And what I mean by that is, let's say you were to create a standard, but you made it so challenging to adopt the standard. What'll happen is your teams, they're just going to reroute around the standard and find a way to do it themselves anyway. So make sure we know why we have the standard. So if we're going to create a standard, some professional, it could be an engineer, it could be an architect or a business executive, is going to look at this at some point, and they need to know why. So document why. How does this standard improve outcomes, reduce risk, decrease cost, enable speed? Make it very clear to everyone. It's not a preference here. It's not about ego. And it's not because architecture says so. It's because we're trying to make the business better. And standards should be evolvable. Standards should be reviewed periodically because technology changes. Threats change. Costs change. And the enterprise really needs to have a rhythm about when it updates standards, when it retires old standards, or communicates changes to new standards. Now, the next thing we're going to talk about is anti-patterns, and that's going to be something that's fairly significant to talk about. So what is an anti-pattern? Well, let's talk about anti-patterns and bad standards, for example, and bad principles. An anti-pattern is, realistically speaking, what you don't want to do. And there's lots of organizations that have patterns of behavior you don't want to do. So we'll talk about what those anti-patterns are. So some companies have slogan principles, but they're completely worthless. We are cloud first. Yeah, what the heck does that mean? We value security. What does that mean? Customers come first, and then the company doesn't treat their customers with any due care because it's a slogan. Lots of companies say they're flat cloud first, and they have 3 of their own data centers, and 10% of their stuff's in the cloud. So what does it really, really mean? And if we create an anti-pattern like this, like we value security, how does that change? And we do that on Monday. How does it change the way the rest of the people do their jobs on Tuesday? It doesn't. So how do we fix it? We go back to that actionable, that testable, that decision-driven language. So contradictory principles we have to be careful of as well, like centralize everything, empower autonomous teams. So autonomous teams and don't give them any guidance. Well, that's really going to be an interesting thing. Everybody's going to go in their own direction. So the fix is we have to add the context and the boundaries. What is centralized? What is decentralized? And why? Too many principles? If you've got 30 principles, you've got none. Because when you overwhelm people with too much stuff, none of it's meaningful at all. So maybe 5 to 10 principles that are going to truly drive behavior inside of your organizations. Now, when we go to standards, let's talk about anti-patterns for standards. So standards that block delivery are obviously a terrible thing. If the standard gets in the way of people doing their business, that's a problem. So anytime a standard blocks delivery because there's, say, heavy reviews for minuscule changes that have no impact on the business, or when we make making outdated tech outdated because it's a standard, or any kind of time we add compliance steps without any kind of way to make it a little easier along the way or automate it, we're making life complicated. And we want to create that standards as more of a paved road to make compliance easier. So if standards are written in isolation by a ivory tower enterprise architect team or a security team alone, no one's going to work with us. And that's realistically why we have to work with engineering, we have to work with the executives, and we need realistic things that the rest of the organization will work. So I generally try to make sure anything I do, I co-design with lots of different people, various stakeholders, engineers, other architects, security, operations, not all of it. I try to bring all that together because that's why we exist anyway. It's shared ownership. We all have different sets of skills. And when you think about that, think about how do we make this better? So standards with no paved roads, that's getting kind of ugly. So that's going to make it worse. So if and when we create a standard, let's add reference implementations, let's add the templates, let's add a starter repo, or an automated check so people know how to go. Because if we say, here's a standard, just follow the standard, but we don't give anybody help, guess what's going to happen? Everyone's going to do it a different way. So when we deal with any of these patterns, make sure that everything is testable, it's actionable, and it's going to be used for decisions. That's how we improve our standards, and that's how our standards become strong defaults. Not a law that's carved in stone, but a strong default that gets used when it's needed and still allows the flexibility for innovation when important. And that's really what needs to. All right. So we are back. Does anyone have any questions so far after our initial morning discussion? If so, drop them in the chat box. We'll answer them. And if you're here and you're learning something, you're having a good time, maybe like this video, subscribe to this channel, and hit the bell to be notified of new videos to help you in your architect career. Maybe share these videos with a friend. It takes a lot to put these in production, and we really do these to make sure that we can help as many people as possible. So see if any questions pop up. As a reminder, if you just got here, tomorrow we're going to run a webinar about how to become an enterprise architect. We'll talk about what we do as enterprise architects, the actual skills you need as enterprise architects, what hiring managers are looking for as an enterprise architect, how to build an enterprise architect portfolio that managers actually want to see, that proves you're a good architect, and much more. The webinar is free. It's on Zoom, so you can ask me any question you want, and it is in the chat box. Adrian's saying it's just as hot in Phoenix as where I'm at. I think that's pretty cool. Hunt Valley is also, Maryland's also pretty hot there. So D. Lassiter, it's so nice that you're here as well. So let's also see, maybe other people tell me what it's like where you're at. I can tell you it's always hot where I'm at. So if you're still here, it doesn't look like I've seen any questions pop up, and that's okay. Maybe I'm doing a go. Now there's some. So there's there. So let's, can I give you an example of a standard compared to a principle? Yes. But you know what? I'm going to spend more time on that when we actually do the lab part. So the answer is I am going to spend lots of time on that because it's a good question, but we are going to handle that in a very process-oriented way. So I'll give you some deeper examples of that when we go through our actual live architecture lab, because it's a great question, and I promise to get to that. Any others? How do you make standards relate to strategy? So if we look at where we're going, and if we look at everything that's going to take to get there, then everything we do should be completely aligned to that. We should be using architecture patterns that get to us to that same goal. We should be using technology strategies that get that to the goal. So if you really think of architecture as alignment, everything we do, if we come up with a standard, that standard should get us to a goal. For example, outside of tech, if we were to make someone a Olympic weightlifter, everything that would be standard in their routine, their diet optimized towards power and power training, their physical training routine optimized towards power training. The suit that they actually wear is optimized to that spring in the hips that are part of an Olympic lift. So everything is there. So that's really what we're talking about, is making sure they align. So, asking, is this pointing to the goal, or is this pointing in a different direction? Because in most cases, what you find with an audit is we want to go here. And we want to go here, but our processes are taking us here. Our employees are paid or compensated bonuses to go this way. And at the same time, our systems force us to go this way. So that's the real issue. So all about mapping them and aligning them. Great question there, Andy. Are there any specific architecture tools you recommend in most enterprise environments, such as Linux? No. I don't care what tools you use. In fact, I will tell you that the worst enterprise architecture practices I've seen are the ones that use the most rules. So the real secret of making your enterprise architecture practice work is the following: making sure your architects have the business acumen and executive skills to be taken seriously by the executive team. Because if they're not, the executive team won't pay them any attention. They won't talk to them. They won't listen to their architectures. And what you have is a practice that creates documents that no one cares about. The second thread is making sure that that practice has the right people in it. So I don't need a whole bunch of architects that are all tech whizzes. I got engineers for that. I need my architects to truly understand architectural trade-offs, strengths and weaknesses, what's going to happen long-term as a result of their decisions. So keep that in the back of your mind. The biggest concern that I have is really related to where the practice is going. The people, are they going to the same thing? Are they focused on the right thing? Are they focused on strategy and guidelines? That's what I care. Are they bringing us to the right goal? So that's really what I would say. Not about tools, about strategy. What is an anti-pattern? Is that the question? Or where would you use an anti-pattern? I see it happen all the time. An anti-pattern is where someone's used to doing something a certain way and they just keep doing it a certain way. They pick a favorite tool, they pick a favorite technology, and they go that way without actually thinking what it's for. I like this thing. I am the serverless architect. And then everything is serverless, even if serverless costs 20 times more and doesn't perform as well. So the real patterns are architecture patterns, or what you don't want to do. So you don't ever want to use an anti-pattern. You want to look and find the anti-patterns. And that's what you want to turn into the proper pattern. So that's really a great question. And that's really the key to remember. Great question. So at this point, I'll see if there's any questions, and and where I am on time. Chris will be is in charge of that. And if we're ready to go, we'll bring in the next questions. If not, I make sure we'll address them at the next question. Chris, are there any other questions back there? And then I'll get to Andy's. I see Andy's question about when speaking about standards, do we teach technical and processes the same things? So when it comes to actual standards, you know, a process and technology are two very different things. A standardized technology standard could be like your web demilitarized zones are going to look like this. A process is how we actually do things. So don't treat them actually as the same. So when you think process, think business architecture. Think that phase where we're focused on the business architecture, we're focused on the value streams, or how we go from raw material to product, focused on how people actually do their jobs. And that's more where the key processes are going to be there. Now, we will also have processes for technical things. For example, what happens if a company is breached? The processes, the standards, the guidelines, those kinds of things are there. But generally speaking, the business things and the technology things, let's say they're equally important, but let's just say they're handled differently. Hi, are there standards that rule the definition of standards? Well, yes. Organizations often use frameworks, whether it be an ISO framework or a TOGA framework or a NIST framework or an ITIL framework, and they actually define how standards are governed, documented, and enforced. And that's the validity of using one of these types of an enterprise architecture framework is it's making sure that everybody is playing on the same page. Now, that's the theory. Now, here's the reality. In most organizations, even if they follow a TOGAF methodology, say 80%, they don't actually follow TOGAF as actually TOGAF. They create their own standards methodologies internally. They'll come up with their own naming conventions for how they name a document. They'll come up with their own governance models and approval processes and even standard templates. So the key is when we work with frameworks, it's just a guide. It's just a place to kind of think about where to start, where we're actually going, and then we should be in great shape. Great question there. All right. So I don't see any others there other than the first one, which we're going to get to as part of our actual architecture lab. So what we'll do is we'll get back to the content here, and then we will see you all in a bit. The next one's going to be reference architectures. And yes, it's very similar to what we covered reference architecture last class, but it's going to be on a different take, more on the utilization of them and getting them bought in and getting them used, because we don't want to just create a reference architecture and have it go nowhere and not be used, because that brings us back to architecture theater and we don't want to be there. Okay, let's continue our discussion on how to scale enterprise architecture decisions. So today we're going to talk about reference architecture patterns. And again, I will make sure this doesn't become an architecture paperwork discussion. So if we're going to scale as enterprise architects, if we're going to scale as an enterprise and increase the velocity of what we do things, reference architectures are going to be a big help. So first we're going to talk about why reference architectures exist, and we'll talk about how that actually helps us scale. Now, in reality, in the enterprise, we often don't lose and become inefficient and have architectural failures because we can't build things. There's plenty of people that can build things in our organizations as a rule. Generally speaking, we lose because we keep rebuilding the same decisions again and again, over and over. And we keep getting different outcomes because we keep doing things in various methods and they're all different from each other. So if we're going to do an experiment and there's 50 different variables, we'll never know what happened. And that's really one of the challenges we have in enterprises. We've got so many people dealing with so much technology, which creates so much complexity, so much inefficiency, and so much cost. But it also increases risk here. So we've got to find a way to do it faster. and scale so we don't have to approve every decision. And it's one of the places where reference architectures are going to help. So in the organizations that are challenged, every team starts from scratch every single time. And usually on foundational things like identity and integration things and how is it going to be logged, how is data going to be moved. Now, that I want you to think about 3 different chefs making the same meal. If there's no exact recipe, the meal is going to be different from all 3 chefs. Some are going to be great, some not so much, and maybe they're all great, but just not what you need. So that's the thing. We can't have a world of inconsistent quality. We can't have a world of inconsistent security. We're real secure in this thing because it followed the really good rules, but not this, not at all. This is a easy way to break into our systems. And we can't have inconsistent delivery speeds. So reference architectures are going to exist because we don't want our architecture teams, we don't want our engineering teams making these decisions from scratch every single time. Because they're very smart, but if everybody does it differently, we're not going to have consistent results. There's going to be many variables that are going to go on. We're not going to know what's working, how it's working, why it's working, and we'll likely have some security challenges along the way. So when we think about reference architectures, they're going to take the principles and standards, which we've previously talked about, and turn them into practical patterns that teams can actually use. So if you view reference architectures are how enterprise can scale good decisions across a lot of teams, then you can view enterprise architecture as that force multiplier. It makes everything so much more efficient. So we're going to, in this session, cover really 3 things that you'll be able to apply immediately. Reference architectures versus solutions defines. We talked about them a little, but we'll get in more detail in here there now in terms of both what they are and what they are not. We're going to talk about when to standardize, where your reference architectures are going to deliver you the biggest ROIs. And then we're also going to talk about how to communicate your reference architectures for adoption. Because if no one uses them, it doesn't matter what or how pretty they are because they're serving no purpose. So we have to make sure. So that's what we're trying to do. I'm curious, for those of you that have been out there working in tech, put it in the chat box or the comment section. And how many of you have seen 2 teams in a company build the same thing? Or a company that has 5 different applications, or 50, but at least 5 doing the same thing. And you can't understand why you've got to log into 5 different systems and waste half of your time all day to be able to see the same thing, or parts of information in 5 different places. And you think about the inefficiency of that, of the employee time, which is something we're trying to do on the process side, but also on the cost of that and the security weaknesses of having so many options in your system. It all becomes fairly important why this matters. So let's start with reference architectures versus solutions design, and we'll obviously get into more than that. I'll start with the simple definition. A reference architecture is a reusable pattern for a type of problem. So, a reusable pattern for a type of problem. How would you secure a web app in general? Great place for a reference architecture. What does your demilitarized zone look like for an extranet environment? Great place for a reference architecture. So it's just something that's reusable for a particular kind of problem. Now, when we look at a solution design, that's going to be very concrete for one single project. So reference architecture is the playbook. The solution architecture, the solution design is the game play for just this match, if you will. So when we typically think of reference architectures, and we'll talk about reference architecture versus solutions architectures, but reference architectures are the building blocks and the relationships. They're the main components that we have and the way the components fit together. That's a reference architecture. The reference architecture, we may have key data flows and integration flows that we can do for when we want to integrate with other things. In a reference architecture, we can realistically show non-functional patterns that matter for security, reliability, observability, or even resilience. And potentially even the shape of the solution at the conceptual level, the logic level, not at the actual solution level. And the key here with our reference architectures, they're usually technology agnostic. So I can choose between AWS, Azure, or Google based upon my needs, the price they're charging me, what have you. And we're typically We may specify some patterns like an API gateway or OAuth or central logging, but they're not going to be specific for any kind of SKU or subnet size or anything that's too detailed or product services. So keep it in that perspective. So you can standardize an event-driven architecture, analytics, onboarding flows, payments, transaction flows. Now, when we look at the solution architecture or the solution design, that's completely different. Those solution designs or solutions architectures are tied to one particular project. Maybe the solution architecture includes AWS EC2 instances, EBS volumes, for example, an AWS Internet Gateway. So very specific at that solution architecture level. It might have a SKU, the product number, part number, and the exact regions on, say, a cloud provider. So you'd see that in a solutions architecture. You might even see certain levels of the details of how things will be configured, not from necessarily a CLI level, but configured in terms of an architecture level. And even the sizing and performance characteristics. You might see in a solutions architecture the number of CPU cores and DRAMs in the virtual machines you usually would that they would have for a certain application. So you could see that. You could see the sizing and performance characteristics of the links. So the network topology, so it's very detailed. And if you look at solutions architecture as having the messy details of the architecture, where we focus enterprise architecture as the big modules, then you'll typically feel fairly comfortable. And that reference architecture is more that enterprisey architecture kind of approach, and that solutions architecture is kind of that detailed one project kind of thing. So that's what we're trying to do. So there's obviously a key distinction between these reference architectures, solutions architectures, based on a lot of things. One, the lifespan of something. The reference architecture will last a lot longer than the solutions architecture because we may use the same architecture pattern, but with a newer model of the same kind of firewall. Like maybe we had older firewalls, we're swapping it out, but the demilitarized reference architecture is the same. Maybe we're writing different reference architectures for different audiences. I promise you, the chief information officer does not want to see subnet sizes, but they might want to see some of the reference architecture patterns or the purpose of why we're creating these. Sometimes we need a purpose-built solutions architecture. Sometimes we need a purpose-built reference architecture. So what I want you to think about first is the scope. Reference architecture, big, high level, and we can derive many solution architectures from them. A solution architecture or a solution design is one design, one problem, one project, what have you. So now the lifespan of a reference architecture could be years. The solutions architecture could be when the product wears out or is given up by the people that make the product. Same thing with, for example, if we're dealing with an audience, who's going to view these? A reference architecture is going to be reviewed by many teams and many architects across the organization. The solutions architecture is typically going to be the one team that designed it and potentially the team that installs it. Now, obviously, it'll probably go through some kind of architectural review board where we'll all see it. But who's the main focus? The main audience of the solutions architecture is more of the technical people along the way. Lots of the teams that are focused on that one thing. For reference architectures, it's kind of the whole organization potentially. And reference architectures are to guide a decision. The solution architecture is to implement decisions. So here's how you would do it. Okay, here's the vendors you pick. That's your solutions architecture to do it. And that's realistically speaking what you're thinking about when we talk about reference architecture versus solutions architecture. So the next question is, why don't we just standardize everything? It would add a lot of speed, right? And that's not necessarily where we want to talk about. So there's times where we want to standardize and we get a lot out of standardization. There's also times where we don't want to standardize. And we're going to talk about that next. So when do we standardize? Well, it's all about the return on investment. We're not doing any of these things for control. We're doing all of these things for a return on investment. So let's talk about when we would actually standardize. Often when there's high reuse patterns,
Because if I got a high reuse pattern, it would make sense to create something that everybody's going to use. Where would be another place that I want to come up with a reference architecture? High risk architecture. So if I use my best and brightest minds to create the reference architecture pattern that's going to be the best for a high risk environment, we want that followed because we don't want any deviations from the plan if we know it's high risk, especially if we know why it's high risk from a business perspective or a security perspective or a network perspective or whatever it is. And typically things that are expensive, high cost. Because if they're expensive, we want to look for the optimal way to do it at the lowest cost and then work off of that pattern as opposed to teams trying to reinvent the wheel and learning the hard way that we spent too much. So again, standardization is not about controlling teams. We're not trying to just control people. What we're trying to do, again, is that paved road concept, speed it up. It's about saving time, and it's about saving expensive mistakes. So here's a good rule of thumb. Standardize where getting it wrong is expensive, dangerous, or even frequent. That's what I would think of. Now let's talk about high reuse. There are some patterns in many organizations that are typically high reuse. And these are the patterns we're going to implement over and over. Authentication and authorization, we use that kind of everywhere. For the most part, the way we would integrate to, say, an API or an API-based integration. We're probably linking logging and observability to potentially a single set of tools or a central log somewhere along the line, or how we would do it or how we would send it. We typically have onboarding workflows of, say, new vendors or new employees, or even new customers, potentially speaking. We may have payments and transactions, and we want to get that right the same way every time. We don't want to mess that up. We don't want to lose orders because we got it wrong. Maybe how we would take data in and ingest data and maybe transform it. Again, that would be a great pattern for a reference architecture, because these will do a couple of things. They'll save time, and they'll build that kind of organizational knowledge and memory where the organization knows what to do and they stay on the straight and narrow, which is the plan for best success. And, I'm sure for those of you that have been in tech or even in other industries, if it's the 10th time you've done something and every single time it's going to take a debate, that's really slowing things down. It's costing a fortune, and then you've got a repeatability problem. But if we can figure out how to do it, and we agree this is the best way to do it, and then we keep doing it that way, at least as a pattern, it's great. So high reuse, like we talked about, yeah, that's where you're using your reference architecture. But what about high risk? Ooh, you definitely want to find the best way to do it here, because high risk means a lot of bad stuff can occur. So high risk could be things that are, say, security sensitive. They could be regulatory heavy, and they could be in challenges like that. So let's think about high risk things. If you're dealing with personally identifiable information or protected health data, that is a high risk for lots of things. Lots of bad things can happen with that. Financial transactions. That is high risk work. We can't have people figuring out everybody's accounts and how to steal money from people's accounts. So financial transactions, high risk. If you bought something and you paid for it and nobody knew about it and you had to pay for it again, nobody would be happy. I promise you with that. If money was just lost, for example. So transactions are high risk. We've got to get it right. Identity and access. Well, wow. You get that wrong for the most part and you're hacked. So, that's one of those critical patterns that's high risk that we want to get right. Mission critical operations where downtime is expensive. Look, there are environments where mistakes can be catastrophic. Imagine certain power plants, going down because the code was bad. And all the things that need power for potentially even to save lives. Of a hospital. What happens when a hospital goes down? We don't want to experiment there either. What about businesses that lose $1 million or more a minute when they're not doing work? You don't want those systems go down either, so they're high risk, and that's why we come up with standards that are really well thought out. So we constantly use reference architectures in high risk areas. And we bake it into the controls by default. We've got approved trust boundaries. We've got encryption expectations built in. We've got audit-ready logging. We've got how do we want to fail? Because you can fail open, fail closed, and these all determine what you need to do. But we determine what our safe failure margins are, safe, fail, closed. We come up with the clear and non-negotiables. And that's what we're doing. For any of you that have ever been, say, in cybersecurity, and you've been in a company and there's been an incident, and you can answer that in the comment section or the chat box or wherever you're at. And when you all of a sudden there's a post-incident review, and people say, well, what happened here? What it looked like? And you find out we didn't have any consistency anywhere. Well, we see that all the time. And reference architectures reduce the unknowns. They reduce risk. Now, where else would we want to use reference architectures, especially in our enterprise architecture practice? High cost. Expensive platforms, expensive infrastructure. We want to get this right, especially when we're dealing with expensive data platforms, integration backbones, identity providers, enterprise observability tooling, any kind of networking designs, because that can get fairly expensive fairly quickly as well. Because if you're going to invest millions in a platform, the fastest way to kill your ROI, your return on investment, is to let every team figure out a funny way to integrate it differently. But if we've got that reference architecture, we're protecting that investment by defining how the teams can use the product, what is actually supported, what's considered the happy path that'll happily move forward. And if there is an exemption, and there will need to be exemptions because not everybody can always follow the same path. Sometimes there's a business need that will force an exemption. And under those cases, how do we handle exemptions? Because we have to figure that out either, because we can't rubber stamp not in compliance, deny. So I kind of look at it. Here's the quick test that I kind of look at with regards of, should we create a reference architecture? If the pattern is frequent, dangerous, or expensive, it's a good candidate for a reference architecture. But of course, none of this matters if people don't use what we've published. So let's talk about making people adopt your reference architecture and putting it into practice. Well, in order to create something, we have to get an adoption and a consumption plan. So we have to find a way to do so. And it's not just a communication problem. If it's not adopted, it's often a product problem. So if you want teams to use reference architectures, the teams have to feel like there's something in it for them. And that means the teams need to feel like the reference architectures will save them time. The reference architectures will reduce risk, and the reference architectures won't trap that person in bureaucracy. Because if we create ridiculous bureaucracy, you will see the creative and insecure workarounds and expensive workarounds people will create so they can do their jobs. So we don't want to trap this in bureaucracy. So if we're dealing with a reference architecture, how do we communicate it? Make it simple. Maybe a diagram and a few notes. And at minimum, a reference architecture should include one main diagram, typically named building with the named building blocks that are there, whatever the data flows are and the control flows are, and any kind of supporting notes of when to use this reference architecture, what are the constraints on this reference architecture, what are the variations on this. And if you think about it, remember these have to be consumed by people that are limited in time as well. So if your reference architecture takes 40 minutes to understand, it's not going to get used in a 2-week sprint where everybody's in a rush. So I like to say, ask yourself these questions. Because every consumer of your reference architecture, realistically speaking, is going to have 3 questions. And you need to answer these questions clearly before you post it out there. So the first thing is ask yourself, when do I use this? Because that's what the consumer is going to be concerned about, your clients and various other either architecture practices or engineering practices. What do I do with this thing? So before you put something out there that you create, ask yourself that question. When do I use this? And make it clear, because that's going to be key to get it consumed. Use it under this circumstance, after this circumstance. Great. Break glass for this, what have you. Don't use this architecture for situations Alpha, Bravo, Charlie, what have you. And if you're not sure, here's a decision checklist. Well, wow, how valuable is that? Here's a solution that's pre-made for you. Use it under these 5 circumstances. Don't use it under these 3. And if you're unsure whether you should or you shouldn't, here's a checklist. That's something that's valuable to the user, because they could pick it up and say, well, 5 minutes, yes or no. This helped me a lot. Yep, good. It doesn't help me. Well, that's okay too, but at least we checked. Now, the next question I ask myself about a reference architecture because your clients are going to ask something similar too, is what do you have to follow? So if you've got a reference architecture, how would the person use it? So this is not negotiable. And this typically things include, say, various security boundaries or data handling requirements or ingestion constraints, whether it's audit logs or repeatability. And that makes it clear, if you're following this, do this. And that's what people need to know. Now, the third thing that I ask myself, and I suggest you do the same, is where do I have freedom with this thing? Meaning, is it so locked down that I can only use it this way? Or can I use this pattern and tailor it to my needs? Can we still innovate around it? And there could be, in certain cases, like we may have options that include a specific tech choices within an approved set. We may have some deployment model variations. It could be done this way, or this way under these circumstances. We could have some internal module libraries, but the key is we want to keep it simple and easy to follow. Because if you don't explicitly say where the teams have freedom, they'll assume they have none, and then they'll bypass the whole thing. So a lot of this is making sure someone consumes these reference architectures and is willing to use it. So we want to prevent red tape, but we want to also make sure people follow things that are the approved path, and we want to speed it up all at the same time. So one of the best moves you can typically make is to separate your guidance into 2 sections. Musts, shoulds, and mays. And that's one set, and then one set that you need to think about. And what I mean by that is there are some patterns in your reference architectures that must be followed. Hard requirements: controls, safety, compliance, critical interoperability. This must adhere to these. Now, we may also have should. So we strongly recommend you use this. That's the paved road you plan for people. Now, we may also create a may section, optional choices at the team's discretion. So here's what you must do. Here's what we recommend you do. And here you got a little bit of ability to tune it along the way. And when you frame it like this, it doesn't feel like you're limiting people's options, because you're saying, hey, these are the approved patterns for this. These are what we prefer to use here for these reasons. And over here, do what you need based within reason, because we're not trying to lock you in. We're just trying to speed things up. Now, great. We talked about how to create it. But you can write the best document in the world, the create the coolest architecture things, and if nobody sees it or knows about it, well, guess what? You haven't created much. So let's talk about distribution and adoption channels of your reference architecture patterns. So where do you keep it? How do you bring this document to life where people know about it? How does it spread? Well, for one thing, we typically want to have some central architecture repository. And maybe it's a central catalog, maybe it's a portal, maybe it's a corporate wiki, for example, or a pattern library, for example. And you want to promote it too. So next time you're on your architecture review board, here's a reference architecture we want everybody to see. Every time we've got a new project kickoff, for example, here's the reference architectures. We build real communities. So we have conversations with people. We've been working on this, and find some champions along the way. We've been working on this. Several of your associates have used it. They said it streamlined things along the way. Build the buzz around it. Build the marketing campaign. With any enterprise architecture, the reality is, anytime we make an architectural change, we've got to build a community around it. We've got to promote it. We've got to create a cultural change around it. Well, this is really much of the same thing. We're just saying, now that you've got your document, you've got to market your document the same way your corporate employers create thought leadership documents and then a marketing plan around that. So the more you market the reference architecture, the more people know about it, the more it will be used. So keep thinking about where you can put them. Make the reference architecture come with assets. So if you're going to download certain things, make the reference architectures available there too, if you've got the authority. Starter, repos, templates, CI/CD pipeline defaults, example configurations, any kind of automated check. Try to get it wherever you can. And if the reference architecture is a picture, and but you've created a paved road that's not real, teams will build their own road. So that's why we've got to be consistent with this, and that's why we want to write them a certain way and market them a certain way, because reference architectures, they're a living product. Ask the teams after you create one, did this help you? Was this pattern easy to use or hard to use? If they tell you it's hard to use, thank them, and then figure out how to make it something they can. And that's the key. In marketing, you ask the clients what they want. So ask the clients what they want, create it, get feedback on these, because you want to be a help. Now, ask the team, especially as enterprise architects, we often have to go to the more technical people for other things. Ask them, where do you need exceptions? Like, if here's our reference, what are the cases where you might need exceptions? Well, we create the reference architectures, because two things will happen. When people are part of creating it, they'll be very bought in. But more importantly, when people are there and they approve it and support it, they'll be more likely to adopt it and use it when they were part of the creation in the first place. So ask the teams this. And ask the teams, what are your bigger challenges that it would be worth it in us trying to come up with standard patterns to save you time? What should we do next? And guess what? Your customer tells you what to build, and you're building what your customer's based. And the key is, check, are these used? If not, tune the reference architecture and figure out how to make it more usable. Because if you don't, you're not going to get that adoption. You're not going to get that trust. So here's the connection back to our guardrails, where we started talking about principles, standards, and reference architectures. Remember, principles are like decision rules. Standards are like paved roads. And reference architectures are where principles and standards become usable patterns, where strategy turns into repeatable design choices, bringing it to life. So reference architectures will scale decisions across many teams. They're not solutions architectures, they're reusable patterns. Standardized patterns when they are high risk, high reuse, or high cost. And tend to work hard to communicate for adoption of any kind of reference architecture or whatever you've created. Make it clear in these one diagram on a reference architecture, clear usage guidance, non-negotiables versus freedom, and make it a real paved road so it helps. Because if teams can't communicate decisions without you in the room, you've got a challenge. But if teams are able to make decisions with things that you've pre-created according to best practices, you've scaled the architecture, and that's the goal.
Okay, well, we're back. We're back to answer some questions. We're back to check in on everyone. So let's see if you have some questions. I did see one question came in right around the time of the last video. So I was able to actually draw a graphic to try to answer that while we actually do this video, because at this time. So we'll bring that in. But I also want to see if you have any questions. So the first question is when a reference architecture is reviewed, does it imply a review of the associated solutions architectures to currently used systems? So let's kind of walk through a reference architecture We'll bring that reference architecture to a solutions architecture, and then we'll talk about how we're going to use it moving forward. Because it's a great question that you had there. So here's an example of a reference architecture I designed for demilitarized zone. So let's say we had a very high security web application that had a lot of hits. And the way we would typically secure that is we would use a content delivery network on the outside of it with some DDoS protection. We would typically have a network load balancer front end, a couple of next generation firewalls from, say, vendor A. Behind that, we would typically have another set of next generation firewalls behind a load balancer. On the load balancer itself, we typically put some kind of a web application firewall. The virtual machines behind the firewalls will typically have endpoint protection, like a host-based firewall. For example, they'll typically have some anti-malware type of a thing on there, maybe an ADR system, for example. And then we're going to send all the logs to a Siemens source system. So this is the new reference architecture pattern. Now, this is for really high security web apps. Not all web apps are going to go to this. So will this architecture pattern that I have shown be brought to all old web apps that maybe only have a single set of firewalls? No, because maybe they don't need to be there. But what this means, assuming we've got the reference architecture and it becomes the standard, that all deemed high security web apps will actually meet this pattern. Now, why are we doing this? And then let's talk about the difference between the solutions architecture. So this solutions architecture could be Akamai that's chosen over here. These load balancers could be from F5 if we wanted it to. The first layer of next generation firewalls could be from Cisco. The next generation, the other next generation firewalls can be from Palo Alto. Maybe this WAF is also from, say, Palo Alto. Maybe this endpoint protection is from whomever, whatever. And we don't need to pick out a Siemens or vendor here, but that's realistically speaking. And why did we create this reference architecture? Because this means if we've created this, if we created the reference architecture without these vendors from a security, from an enterprise architecture perspective, the next time the security team wants to get a new set of vendors, they don't have to go back and we don't have to start an enterprise architecture process. So if they want to change this CDN to CloudFront from AWS, and they want to change this network load balancer to an AWS network load balancer, we don't really care. Now, if they change this one to a Palo Alto firewall, we don't care. Checkpoint's another security vendor. So if they switch from Palo Alto to Checkpoint, we also don't care from an enterprise architecture perspective because these are just vendors. And from an enterprise perspective, we just care that the trade-offs are met by what we need. So that's why that's why we're creating it, so that in every single architecture, the security team doesn't need to go back to the enterprise architecture team and back to the C-suite and the board to just change a vendor. So that's how we speed it up. And that's the whole point of doing this. So I hope that answered your question, because that was a really good question. When I saw it come in, I was like, good, I have a chance to draw for a couple minutes. Great job. So who else has any questions? Are there any others? Nothing yet. So let me do this. There was a question that came in last time that I said I would save for the lab. So I've got two things that I would talk about today on the labs. One of the labs, we're going to have fun with architectural trade-offs, which we're going to do right after this next section. But let me kind of give you maybe walk you through an example or two of enterprise architecture standards versus principles. Going back to what we talked about before, the principles are that high-level decision guidance, and a standard is where we get into some mandatory direction. So that principle is how and why we're going to make a decision, and the standard is these are the rules you must follow. So I'll give you a principle. Now, there were a lot of organizations, and they've since learned that we're cloud first. And what cloud first was, cloud services should be preferred over on-premise infrastructure when they can provide sufficient security, scalability, resilience. That's a principle. And an organization created that because they thought it would to guide strategic decision making, to establish the organization's direction migrating towards cloud, and it encouraged modernization of whatever platforms they had. Now, the characteristics to that principle were very broad. Hey, use the cloud when you can. They were very flexible, and then they were outcome oriented. Now, when we want to get granular into those standards, we're getting really granular. We could come up with a standard that says all production workloads must be deployed to approved cloud providers. And then we would come up with another standard that would say approved cloud providers are Amazon, Microsoft, and Google. And then we might even come up with another standard that says all cloud environments must use an enterprise landing zone with approved IAM controls. And see, when we go to that standard, we're getting very specific. It's enforceable that you use the right cloud provider, the right service, and it's operational. So let me give you another one, something that's, not just a buzzword slogan like cloud first or AI first, but, a real guiding principle. Let's say security by design. That is an enterprise architecture principle. And what we're talking about, that means security is going to be integrated into the systems throughout the entire solutions lifecycle. And the point of something like this is to drive proactive approaches to security, to establish security as a high priority and a responsibility of everything that moves forward. And enterprises are doing that for risk reduction. So the principle is security has to be integrated into everything we do. Now, we can come up with standards, and maybe the first standard is all applications that must support multi-factor authentication for privileged accounts. We could come up with another standard that says all data classified as confidential must be encrypted at rest and encrypted in standard. We can even come up with another standard that would say all internet-facing APIs must pass enterprise security reviews before a production deployment. So as you can see, what we're really doing there is we're getting very granular. The principle is the direction we're going to go in, and the standard is everything that we can check. Hope that kind of makes sense. That's why I wanted to give it a chance where I could spend a good 10 minutes or so on just this question, because it was a great question you asked, but I wanted to make sure we gave it the time that it was due. So while we wait to see if there's any questions, if you're having a good time, hit the like button. If you're not a subscriber, please subscribe and hit the bell to be notified of new videos to assist you in your architecture career. When this Enterprise Architecture Fundamentals Bootcamp is over, we're going to release a completely free ebook with an incredible amount of information and graphics and documentation on enterprise architecture to help build your enterprise architecture career. It was written by me and my good friend Jasser, who's a fantastic enterprise architect, and we'll be releasing it on the last day. So please, if you will, sign up for it. See if there's any others. You see the value of standards, but what about systems or software specifics? For example, the specifics of processes supported by SAP, or the specifics of a Palo Alto high availability design that can't match the standards. So that's why we're actually creating this. So let's say we have a standard that this company must follow, and then we have a vendor that can't meet that standard. Well, if we truly care about that standard and other vendors support that standard, we just don't use SAP, or we just don't use Palo Alto. We use a competitor to SAP or Palo Alto, and those are the examples you gave that would actually meet that standard. So that's realistically we can do. Now, what if for some reason we have a strategic relationship with a vendor like Cisco? We've been working with them for 25 years. We trust them. Their executives and our executives talk quarterly. The company's got a couple $1 billion in Cisco infrastructure investments already. Cisco has committed features for them in the future to match their needs. Then the company will have to make the determination is, can I tune my standards to meet that product and feature set of the company like Cisco that I want to deal with? And if the answer is no, that architectural trade-off is a non-starter, then they have to use another vendor regardless of whatever they've invested somewhere else. So that's kind of why we're doing this. And the reality is there's going to be a lot of things that we evaluate our vendors for. It could be cost, it could be reputation, it is often support, it is our level of trust in them, the investment we've already made in them, and the results we've got from vendors. So, the point is that's why we think strategy first, then we think architectural design first, and then last is when we go to the store. If we know that our recipe calls for eggs, we know we need eggs. It doesn't matter where we get our eggs from. We know we need eggs. Hope that helps, Andy. How to define what should be covered by a reference architecture with respect to an organization's business processes? Well, they're not necessarily the same. A business process is how something's going to be done. A reference architecture generally refers to a technology strategy. So first, we determine where the company is going. Then we determine what the ideal process is. After we know the ideal process, then we can start designing our reference architectures based upon the ideal process. And then after we have our reference architectures and we've got our ideal process, then we can start looking for candidate solutions or vendor products that will meet and exceed those needs. But first, what are we trying to do process-wise? And in many cases, we need to optimize the process. And actually, it's good you brought that up because in many cases, the reason an architecture fails is because there's no process change. So for example, they were hosted in their own data center. They took their architecture from the data center, moved it to the cloud provider, and got no business benefit. And here's the reason they got no benefit. They took tech systems from the data center and picked up the equivalent or different tech systems on the cloud and didn't change the way people did their jobs. So nothing's going to ever get better. It's like moving things from one closet of your house to another closet of the house. They're not going to make you cool. They're not going to make you popular. Now, if you don't know how to dress, for example, and you find a professional shopper that knows how to dress you, and they're the kind of people that send you for the right haircut, the right grooming, the right stylist, they teach you how to walk and talk. Now, that will have a big impact on someone's life, just like all those movies where they take someone and then they give them the full makeover. And the reality is that does work because you're changing everything about them. But just going from closet one to closet two. So always start with the business goal, then the optimal business process to get there. And then everything else comes secondary. Great question. All right. Why don't you give me a hashtag enterprise architect so I know everybody's awake? We will go through. We've got a little more video content, I believe. And then after that, what we're going to do is we're going to have our fun architecture lab. And we're going to do a deep trade-off lab, and we'll be lots of fun. And that's really the biggest thing we do as architects is evaluate trade-offs. So we'll have some fun with it. Let's get back to the content.
Now we're going to talk about trade-offs and how to make decisions when there's multiple trade-offs, like an enterprise architect. And I promise you, I won't give you an academic framework this session, but I will give you a way to make decisions faster with less drama and fewer regrets. So drawing boxes and lines is not the job of an enterprise architect. So I want you to think about this, that architecture is not about boxes and lines, but it's about choosing between trade-offs. Architecture is usually about choosing between trade-offs. And here's the reality. There is never a perfect solution. There is never anything that's the custom fit for the organization that's perfect in every single way. Every option we have brings some wonderful things to us, and every option taketh some away. And that's really the trade-off. So there's always going to be a trade-off with the product, where it'll be or service or option or the way we even do work, that it will gain something and will lose something. And anybody can draw a diagram, but we're getting paid to answer the uncomfortable questions. What are we giving up to get what we want? And that's the reality of anything. If you want to lose weight, you have to give up some calories or increase your calorie expenditure or something like that. If you want to build muscle, you have to give up time and get in the gym all the time. And that might be a great trade-off. I think it is. But the key is everything is a trade-off. But at the enterprise architecture level, decisions don't just impact an application. Decisions at the enterprise architect level shape the entire organization. And that means cost. Not only what we buy, but what's the long-term total cost of ownership? And that includes the people, the service, the support, the staffing, whatever. Risk. And risk could be in security or compliance or exposure to various things in business. Speed. How fast can we do things? And that's obviously critical. If the market changes and we can't adapt fast enough, we might not survive. So we always have to think about that. And of course, we're trying to minimize bottlenecks. And, when we're at that enterprise architect level, culture is a big component of what we do. How do the teams work? Who owns what? How centralized have we become? But a lot of that's going to be based upon culture. And if we're going to make new architectures and get their adoption, we may even have to change culture. In fact, we usually will. So the bigger the organization we're dealing with, the more dangerous any of these unspoken trade-offs become because things get really complicated. The more complex a system is, the more fragile it becomes, and a change to one part of the system can make a big change in a very negative way or positive way based upon how you design your architecture to another part of the system. So that's what we're going to talk about now. We're going to come up with a way to make decisions about enterprise architecture fairly quickly. We'll come up with some common enterprise architecture trade-off pairs to think about. So you're not stuck staring at a blank page. We'll talk about maybe even what goes into an architectural decision record that executives will typically read. And I'm going to use generic terms, very simple. Organizations may do things a little different, but we'll talk about general principles. So I'm sure many of you have worked for organizations, and let me know in the chat box or the comment section, if you're depending upon where you're watching this, have been in a meeting where people just argued for 45 minutes, and the real issue is that nobody even agreed what they were trying to fix in the first place. That's what we're going to fix here, and that's what we're going to talk about today. So the first thing we need to do is determine, how do we make decisions? Well, we're going to talk about a model for decision making for enterprise architects. And I'm going to introduce a model that I tend to like to use, but there's so many of these that you can use, and it's just a way to organize your thinking. So what I typically start with is the following model. I start looking at options. The options that I have. We obviously have some kind of criteria that we're looking for. Because as a rule, we've got options, but there's a criteria of things that are going to work for us. And then typically we have to think about trade-offs. Because everything we have could bring something and loses something. And then ultimately, after we've evaluated the options and we've gone through some criteria, must support this, for example, cannot do this, and we've got our trade-offs, then we actually are in a position where we can start making a recommendation. And we can do that because we've actually gone through the decision-making process. And because what have we really done here? First, these are the 10 options we have. And then we've got a criteria of things that we have to, this performs this service, this thing, great, meets these criteria. Then we look at all the whatever other choices that we have left over. And then we say, we've still got a bunch of them. After the trade-offs, which one's going to be the best one that we want to choose? And that's going to be the final step of this. Oops, that didn't go where I wanted it to, but that's okay. We'll move it over to here. So that's really, the way I like to look at it, at least as an approach to start it, because I want to make my decisions the same way every single time. So the first thing we have to do if we've got a decision is to clarify what the decision is. We need to clarify what decision we're actually making. Not the topic, the decision. I don't want to hear we're deciding observability. That's not going to help anybody. But what we're trying to do here is we're trying to standardize, say, the enterprise observability stack for production services. That clarifies what the decision is, what we're trying to do. Very specific. Because often, if people don't know what decision they're making, you've got conflict and nothing gets done. So we have to be very specific about the problem, because architecture is all about, solving a problem somewhere. But if we don't know what that problem is, it brings us to a place where we're not going to be effective. So we first need to start there. Now, after we clarify what the decision is, we have to ask ourselves, what's the problem or the opportunity? Okay, so we want to invest in AI, an AI recommendation engine for our e-commerce website. So the opportunity is we believe that's going to bring in a lot of sales. So that we're doing for an opportunity. Now, we could be considering updating the network, right, for the entire organization. And that might be because there were some network outages in the past. So that was a problem that we're trying to solve. Or is an audit failing? So realistically speaking, if we're going to make a decision, first we need to know what we're deciding about, right? And we need to know what's in it for us or what problem we're trying to solve. Hope that makes sense. And the better we understand that, the better we're at. And if you can't write your decision or figure out what your decision is in a single sentence, you're not ready to decide on it because you haven't clarified the problem yet. You're still deciding. So the next thing you need to do is you need to identify credible options. So once we know what we're deciding, then we have to look at our options and list them out. So what does that mean? So if we've got option 1, what does that do? Option 2, what does that do? Option 3. So if you think about that, why do we need to identify our options? Because we now know what we can do. Now, let's say we have an architectural decision point. Let's kind of look at what our options could be. Let's have some fun with it. So we have to make an architectural decision, and here's one option. Do nothing. If we do nothing, what happens? What do we risk? What do we gain? What do we lose? How does it hurt us? How does it help us? What's the cost of it business-wise? What's the cost of risk business-wise? So that's one option that we can always use. Another option is we've got a primary recommendation. This is the one that we think is best. We'll call it platinum recommendation. And of course, we'll fix the spelling that I'm recording here live at the same time. And maybe we've got option 2. And option 2 is a very reasonable recommendation, like a reasonable alternative. Call it alternative. So when you look at that, now obviously there's going to be various trade-offs of each of these approaches, but you see what our options are. We know what our options are, and we have to map that out. So we've got an option to say do nothing, and an option of the platinum recommendation or a reasonable alternative. But that's realistically speaking what we're talking about. So the next component of doing any of this is we have to build the baseline. Where are we now? Now, why does it matter so much where we're now? Well, it matters a lot. Well, for one thing, the executives are going to love it because you can walk into that executive's office and then tell them, here's what happens if we do nothing. And I promise you that executive will know exactly what that means. Now, the next thing is we can tell that executive, I recommend this one because of this rationale and these reasons, and here's the logic. Here's another option we strongly considered, option 2. We prefer option 1 for X, Y, Z rationale, but option 2 is an alternative. It comes with these options and other options. So at least, when we think about, when we have conversations as executives or with executives, and when we plan to make a decision, these are the kind of things that matter. And that way, it moves the needle forward, because the executive, when they have to make a decision on what to buy, what not to buy, when they've gotten options, they get it. But that's also part of our decision making, because we have to make decisions like scientists and executives, just like they do. So keep it going in the right way, because, and we'll talk about more why there's an option, but ask all of you, put it in the comment section. So how many of you have seen decisions presented? There's only one option. And of course, as if it's the only thing that could be done. Now, if you see something like that, to me, that's not an architecture. It's a sales pitch for a product, and I tend to run far away from those. So the next thing we need to do is define criteria. So before we talked about, options, criteria that we're going to talk about. So let's talk about what those criteria actually are going to be. So at the executive level, and all enterprise architects, we should be focused at the executive level with a lot of our work. There's real discussions we're going to talk about and trade-offs that the business will care about. And one thing to think about is the cost of, or even buying, what's the cost of something? And if so, do we pay it as a capital expense? Or is it something that we can use as an operating expense, such as a lease or, cloud services that are rentable, something to that effect? And what's it going to cost us long term? Now, the executives are going to care about, how long is it going to take to get any benefit from this? Because if you spend $1 billion but don't get any benefit for 10 years, the company might not be able to build that or afford that. Probably can't. So the next thing the executives are going to be cared about, and we are cared about too, is risk. Where is the risk? Is it security? Is it in the compliance area to do this? Are we in a gray area? Are we clean? Because we don't want to get anywhere in a negative compliance environment. What's the risk if we do it wrong? And we need to think about, what kind of risk is it to even do this in the first place? Other criteria that we and executives are going to care about is resilience and performance. What will this do to our business? Will it make our business more resilient? Or will it make our business more susceptible to little outages and things, for example? Now, anything we need to think about as an executive or an architect, doesn't matter, is the complexity and maintainability of your architecture. If you can only hire 3 people in the world that can actually run your architecture, it's not a good idea. Unless you're in some magical business that you just need those 3 people, it's probably not a good idea. You need to have people that can support it. And do you have enough people? And do you need to train people? So, and what's the risk with what we have? So there's that. And of course, there's this new thing. Help us with our strategy or our standards and existing platforms. And if you can't explain to the C-suite or any business leader in business terms what we're trying to get to, they're not going to take it seriously anyway. Now, what's the next step? We have to evaluate trade-offs. Honestly. We can't have any bias or any favorites. You wouldn't want a doctor that only wanted to prescribe one pharmaceutical company's medications. They're biased. That would not be something you're looking for by any stretch of the imagination. Now, neither are we when we start talking about trade-offs. We have to be fair and unbiased. So this is where we earn our trust when we evaluate trade-offs. So for every option that we had, we compared our options against the criteria that we talked about. Option, criteria. Whittled it down. Because not everything's going to meet our criteria. And in a way, we try to do that in something quantitatively. We may build a matrix and say and rank various components of a product, service, or whatever we're considering in architecture, because we know nothing's perfect, and that way we've got a quantitative way to compare things that are unequal along the way. And when we do that, it puts us in a position to quantitatively, scientifically talk about winning options and those that are losing options. And it's going to be a lot easier to actually do that when you've used a fair objective. And we can ask ourselves these questions. Which option wins on speed? Because that's a constant trade-off we have. Which option wins on cost? Because that's a constant trade-off. Which option wins on risk? Which option creates an unmanageable level of complexity that might be hidden? Which level creates technical debt? So we always have to consider those, because that's a real issue in reality. And executives don't hate bad news. Executives know trade-offs exist. They expect to hear the trade-offs. Executives don't like surprises to the negative side. So somewhere along the line, we get to that next step. And that next step is really about making a decision. What do we recommend you use and why? So that's that next step. So here we obviously need to make a choice or make a recommendation. So typically speaking, we want to recommend, explain it. So we're always going to capture the top risks and the top mitigations to the risks. We're going to discuss, for example, in our recommendations when we should revisit the decision. Because, enterprise architecture is not a set and forget it thing. It's a set it with intent and then revisit when the assumptions are going to change. So now that we've gotten through the decision model, maybe let's practice some of the common trade-off pairs that you'll see in enterprise architecture environments. So let's talk about some common enterprise architecture trade-offs. And I'm going to put it in pairs so you can see some of the ones that we typically have. So we'll talk about those questions, but I'm going to tell you how I typically look at an environment, some questions I ask. When it comes to, say, resilience versus cost, because that's the next trade-off we're going to talk about. Resilience, the more redundancy that we have, the more likely we will to be resilient and be able to survive failures in systems. At the same time, our cost goes up. So when someone says, I want to be up all this time, I say, well, how much is it per minute? How much is it per this? How much percent is that? So here's what I ask. What's the real business cost of downtime? Now, if a company wants 5 minutes of downtime per year, that might cost 5 times more than if they can actually tolerate, 50 minutes of downtime per year. By the time we're done with the level of personnel and the change control and all the redundancy, resiliency in the system. So does it make sense? For the clients I work with, they usually need 99.999% availability, but that's for business reasons. But we have to ask that question. When I think of this kind of resilience, I typically think of which part of your user journey is the most critical. Meaning, if your system's down for 5 minutes and then you lose the big order, that's a problem. If the company's website is, look at the website and book an appointment with the sales rep, if that website's down, for example, in a sales business, that might not be that big of a deal. So we have to figure out which part of the systems make the most sense, which business capability. And then we have to typically think about what's good enough and acceptable and what's not, and make sure that everything we do is at least good enough. So when I start looking at that resilience and cost, I don't naturally say everybody needs 99.999% availability. Now, hospitals do. Something in a hospital goes bad, there's some pretty bad consequences. If you're running an emergency services system, it matters. And if you're running a bank where minutes could be millions of dollars, well, it matters too. But that's why we always have to ask these questions. Where a lot of architects fail is when they argue for maximum resilience everywhere. Everything, we need this, everything needs to be super resilient and super redundant. And what ultimately happens is nobody takes them seriously because the cost is crazy for everything. But some things need to be more resilient than others, and that's typically based upon business capability, and that's how we look at that. Now, the next trade-off is speed versus risk. Okay, this is a big one because we can often do things very fast without a lot of controls. But if we do that, risk increases. Now, if we really focus on the perfect delivery, we will make less errors, much less risk, but speed will slow down. So we enterprise architects, when we start looking at how we might be evaluating trade-offs, we have to ask ourselves this question. Where can we experiment safely? Where do we need a formal approval path? Which guardrails enable us to move faster without creating risk and gambling? See, a mature enterprise doesn't choose risk or speed. The enterprise builds systems where they can go fast inside of a clear boundary, while simultaneously reducing risk. Now, the next trade-off I like to think about is standardization versus agility. Okay, this is a big one too. So, when we standardize, we reduce chaos. We improve governance. All really want things. But if we standardize too much, we might lose innovation. So, again, that's a trade-off. So we have to really think and ask the questions as enterprise architect, what needs to be a standard enterprise-wide? Where can teams choose whatever tools they want to use? Is our standard actually going to be supported, or is it just something that's mandated? And if your standard slows teams down and it's not supported, we don't have a problem. And if we automate that bad thing, then we have another problem. So keep that in the back of your mind, because if teams don't get what they need, they're going to find a workaround, and that workaround will be a bit of a problem. Now, let's talk about centralization versus decentralization, another big issue in complex architectures. When we centralize things, it brings us economies of scale, which is a great thing. It brings us consistency, which is a wonderful thing. It gives us really great shared security controls, which is a wonderful thing. Reduces duplication of services, which is great. But guess what? When we're decentralized, teams have more autonomy. They make faster decisions locally. And there's typically tighter business alignment in the way the smaller units are working. So again, which is right for the organization. So we all go back to that business capabilities, and which capabilities truly benefit from centralization, and which capabilities to stay close to the domain. And that's going to be typical in the way we think and how we design our architectures. So it's a common failure mode to centralize everything, because now it feels 100% controlled, and nobody likes that. And then it creates bottlenecks. Now, the way you want to do it is you want to centralize what's going to benefit from being centralized, and decentralize places where there's typically different domains where you're going to get your innovation. Now, the next trade-off we face as enterprise architects and executives, all of these things could be said for most management consultants, executives, enterprise architects, is short-term versus long-term decisions. Now, we enterprise architects have to really think about what compromises are acceptable, and how do we plan to fix them. And we really need to understand that, because short-term versus long-term, it's do we win now? And maybe at the cost of long-term things. Or are we building for a future? And generally speaking, we have to focus on the short-term, medium-term, and the long-term. So with each of these decisions, we have to figure out which we're focused on, which capability would have you. Okay, now let's actually talk about communicating architectural decisions and architectural decision records. And I view an architectural decision record as a memo that an executive is actually going to read, at least if you create it correctly. And that's typically what we're going to talk about. So we are going to be creating architectural decision records that are going to talk about the decisions we made, the trade-offs we've configured, risk, and all kinds of cool things that we'll talk about. And we'll keep it to one page, because executives have no time. And if it's more than one page, there's just no time for them to read it. And we're going to talk about all the key things that matter and why we made our architectural decisions. And we're going to do that to make sure we show what we've considered and why. And this is so important, because without this, people will keep revisiting the same thing again, again, and again. And it costs lots of time and it costs lots of money. So we want to create records of what we've done and capture all the things that actually matter. So we'll talk about that. So in one page, what we need to show is clarity of thinking, a prioritization of what matters for the client, and getting rid of any jargon to make it executive ready. Now, it needs to be very clear. We need to be able to explain this decision in one page. And if we can't, it's probably because we don't understand the decision well enough. So I'm going to walk you through a structure of the kind of things that I would recommend on a typical architectural decision record. So let's map them out one at a time, and I'll kind of give you a visual while I talk you through it. The first thing you typically want on an architectural decision record is a title and a statement. For example, select integration pattern for customer-facing APIs. Something that makes it just clear what it is. An executive can look at it, they can pick it up and read. Well, I probably wouldn't use APIs for executives. Now, once we talk about that, what we really need to really talk about is the context and the problem. Again, very, very, very short, but just call it context and problem. So what do I mean by the context or problem? What was the business driver for us to consider making this change? Was there a technical trigger? For example, did a vendor just go bankrupt and now we need to find a new vendor because our product has never started? And they were key to our architecture. We also have to think about what was the urgency for the change? Is it something we have to do right now? Or is it something that we can do when time permits? So we always want to put that on there, and in any decision record, we typically want to talk about the constraints that were part of the decision making and the recommendations that are there. Now, I typically include an options considered, and I'll show you what I mean. Options considered. So we could choose staying the same, like the baseline. Here's option A, and here's option B. So we have to be very clear with the options considered, because that way it'll help future people understand what changes we made and why we changed them. And then the next thing we want to talk about and be very clear about on this in some bullet points is the criteria, typically 4 to 6 bullets. And I'll show you explain to you what I mean by criteria. So maybe we had a criteria that it costs less than $30 million or $40 million. Maybe we had a criteria that said we have to be paid back within 12 months or we don't fund the project, for example. Maybe there was a criteria that is based upon risk, must be low risk, for example. Maybe we have a criteria that's on resiliency, or a criteria that complexity can't exceed a certain amount threshold, or a criteria that says it has to be aligned to a business capability. So we always have to think what those criteria are that we're actually looking at the product against. And at that point, I typically add something, and every organization is going to do these differently. And if you work in 3 different organizations, they may have a different version of it, but I typically add some kind of a comparison and trade-offs. And here we can actually talk about very quickly which option wins and where does option A win, where does option B win, where does but also where do they win and all they lose. Because there's an option of doing nothing. And that may help us in some ways, but also hurt us in some ways. There's an option choosing option A. What does that get us, but what does it cost us? So we really want to make that clear of what we did in our decisions. And then we really want a recommendation. That's around the time we can make a recommendation after all this has been done. So the recommendation is really what to do. Why? Maybe 2 or 3 bullets. And typically speaking, maybe there's some risks and mitigation. So, because typically nothing is zero risk. So maybe we add a risks and mitigation, which I often do, actually, usually. And what I mean by that is, what are the top 3 risks that are associated with this architecture, and how do we prevent them? And then usually there's even a next steps phase. And that's typically what belongs in next steps. And that's typically what we typically talk about, and maybe we talk about who the owners are and the timeline in that next steps. So if you notice what's on here, what we've talked about, it's plain language. There's no architecture poetry, and there's always a tie back to what matters. The impact to the business, whether that be cost, risk, speed, or even user experience, because that's what matters most for us, is how it ties back to the business. Let me give you a quick example so you can feel how this might read. So we might have a decision that says standardize on a messaging platform for event-driven integration. And maybe the context, multiple teams that are adopting events inconsistently. And maybe there's a need for audit-ready traceability and cost deduplication across teams, because that typically had too many teams that all had different things. And we've considered 3 options. Option 1 is do nothing, and the teams will choose what tools they want. Option A is to standardize on a managed, say, cloud event bus. Option B is to standardize on a Kafka platform. They were the options we had. The criteria were total cost of ownership, time to value, resilience, security, compliance, complexity, and alignment with skills. The trade-offs we considered: doing nothing wins for short-term speed, but it loses because of long-term cost and risks. Now, option A wins by time to value. We earn our money back faster, and it simplifies operations. But we're going to lose portability, and we might be vendor dependent, and that can cost us. Now, if we go with option B, we win in terms of capabilities and flexibilities. We're not locked into anybody, but it's more complex, and it takes longer to get our return on investment. Therefore, we recommend option A, the managed event bus, for 80% of cases, and use option B for high throughput needs, or when you need explicit platform support. And regarding the risks and mitigations, we realize and we acknowledge there's a risk of vendor lock-in by using the cloud-native cloud provider's proprietary tool. We also understand that there's going to be some observability gaps, because we can't see as much information into somebody else's managed systems than we could if it's our own. So the next steps for us are to publish reference architectures, create our starter repos, and define any exception paths that need to exist. But really think about what we were doing here. We didn't pretend there was a perfect option. We made the trade-offs explicit and best fit, and showed why the decisions were used. So it's a 1-page memo. It aligns executives quickly. It creates durable decision history for engineers as well as other business people along the way. And it becomes part of your enterprise architecture portfolio, as well as interview stories for the future. So that's what we're talking about with regards to architecture.
All right, welcome back, everyone. So give me a hashtag Enterprise Architecture Lab, and that's what we're going to do right now. We're going to get into an Enterprise Architecture Lab as soon as we see if anybody had any questions. So if there are any questions, drop them in the chat box. We'll answer them. Otherwise, we'll begin the lab, but I'll give you about a minute or so to see if any questions pop in. While I give you a minute to see if any questions pop in, I'll remind everyone that both on Monday night and Thursday, tomorrow is Thursday, we have a webinar on how to become an architect, where we'll talk about what we do as an enterprise architect, the skills that you need to become an enterprise architect, the certifications that you should get, what belongs in your portfolio, and everything it takes to get hired. So it's a free webinar. It's on Zoom. So I look forward to meeting you. We can have any kind of face-to-face conversation you want there, and it's free. Also want to remind everybody that we've got a book that's going to be coming next week, the last week of this, and that book will correspond to this course. You can go through the course another time, go through the book. There's an incredible amount of content in that ebook and a lot of diagrams to make your learning journey even easier. So I want you to be able to go back to that. Chris, before we get into the Enterprise Architecture Lab, did we see any questions come in? Okay, so is there a best practice approach to the review of the reference architecture? What is most critically or most reliant, and what frequency should it occur? So the key is, if we're creating a reference architecture, it's there for a purpose to guide an architectural decision. And the reality is reference architectures don't change that often. For example, if I have a hub and spoke wide area network environment and I have a hub center and I have a spoke site, I can fairly easily make a reference architecture that involves the remote site's two routers, their primary wide area network link, their backup wide area network link, and for the most part, deploy that same architecture for 99% of the organization's offices for the next 25 years. Because the reality is, it looks like things change fast in technology, but they really don't. They're very similar. Some people think cloud computing is new, but I worked on the frame relay and ISDN cloud in 1993. And I was there with the ATM cloud and the VPLS cloud and the BGP 2547 cloud. And then when the first cloud providers were there, I was there to help design them as well, what the infrastructure was going to be like. So the reference architectures aren't going to change that much. When your reference architecture needs to change, it's because something changed. The business has a new goal that drives a new architecture, or maybe the technology changed a little bit. Maybe we went from a dial-up remote access WAN to a Ethernet line as a primary and a 5G as a backup. But realistically speaking, from a reference architecture perspective, it's just private line and wireless backup. Nothing's changed, even though the speeds have changed. So generally speaking, a reference architecture can last a quarter of a century. Your solutions architectures will periodically change because most things don't change that much. They look like they change that much, but if you truly understand the technology, you'll see that it's the same tech. The first virtual machine was from VMware in 1999. That hypervisor designed by VMware is nearly identical to the hypervisor you'd find in any other Linux system that you'd find in Microsoft, that you would find in AWS, Azure, or Google. Same thing. That same virtual machine. And when the container came out, it's the same container on AWS, Azure, Google. It doesn't matter. So a lot of these things just don't change. The names change. And if you actually really want to have some fun, if you go to the Internet Engineering Task Force, IETF.org, there's an RFC called 1925. And in that, they talk about the 12 networking truths. It's really fun. It includes funny things like pigs will fly if going at a specific speed, but it also talks about networking things like all technology will just come back as another technology with a brand new name. And that's really reality is in so many cases what we have. Cisco had NetFlow back in 2000. AWS has VPC flow logs, functionally equivalent, same thing. Cisco had an access control list on the router in, 1995. AWS put a network ACL in their cloud. Decades later, same thing, just a different approach. Great question. Let's go to the next one. It happens sometimes that the output of one option may lead to an ADM for a wider strategy. Such open local accounts on servers may be an input to security strategy. I'm not really sure I understand what you're saying there. I'd love to help. But what should lead to a new architecture development cycle is a business goal. I mean, if we find that there's a technical issue on the engineering side, either we have the engineers mitigate it or we create a new architecture. But the reality is, even if we create a new architecture, it's because there's a business reason. Maybe a new risk has emerged that didn't exist before. Maybe the organization was hacked and they need a more effective strategy for the future. But there generally should be a reason, a business reason to design it. If we find that servers have too much local stuff on them, that's not an enterprise architect thing. That's a technician level engineering thing to go figure it out. Let's patch the server. Now, if we enterprise architects get given a vulnerability report and an ethical hacker is paid to break into our systems, and we're looking at it as well as the security architects, we enterprise architects are going to focus on that big picture component. The security architects are going to focus on that security strategy to protect the organization, its assets, and its people. The security engineers will be augmenting those security architects on the deep tech side, because again, they're business people. And then we're going to be bringing in vendor solutions architects from the other vendors to try to give us their point. So, that's really what drives it. But when I work as an enterprise architect, I'm not getting anywhere close to what's local and open on these systems, because that's not enterprise architecture. Now, the reality was in my youth, when I worked as a solutions architect, as a principal solutions architect, in those days, we got fairly close to the technology. So what happened when I was a principal solutions architect, the customer would come to us and they'd say, here's our problems. The security architect would have created a strategy, and then we'd give them the products and solution sets to do that. But typically speaking, a fairly different role. If you're an enterprise architect, I want you to focus more on the executives, the key business processes, the business architecture, optimizing the value streams, optimizing the real business on that. And truthfully, that's the difference between an $800,000 a year enterprise architect and someone that's, they're working there, but they're not really getting ahead. Hope that helps. All right, so let's have some fun. So the reality is architecture is an art and a science like medicine. And just like medicine, where there's no perfect pill, there's no perfect surgery. When it comes to medicine, the right medication, the right option is the one that treats the patient's condition, given all their constraints like allergies and health conditions. So now we pull it back to the architecture world. We have, realistically speaking, a lot of architectural trade-offs, but 20 of them are super common. And what we're going to do is we're going to talk about these common trade-offs, and then I'm going to ask you to put something in the chat box to see that you're thinking and acting like an enterprise architect. Because it's never going to be easy. Now, if we understand that architecture is balancing priorities, and the priorities that we're going to be balanced are, how do we enhance business value? At the same time, how do we keep costs under control? How do we speed up what we do, but at the same time de-risk what we do? How do we scale without spending way too much money? What kind of governance structure should we create? Because that can mess us up or assist us along the way. How complex are our operations going to be? What's the user experience going to feel like? And how do we make sure that the people, the processes, and the technology in that company are all running towards the same thing? And that's why everything is a trade-off. First trade-off I want to talk about is speed versus governance. All right, so I've got two options. I can use strong governance to improve consistency, security, and compliance by implementing a series of checks. Okay, everybody in the chat box, tell me what's going to happen if I add strong governance to improve consistency, security, compliance. And we're going to have a series of checks. Is that going to speed me up, or is it going to slow me down? Put your answer in the chat box. This is the first of the trade-offs we will discuss today. More systems to check, more checkpoints, more balances. Does it speed me up, or does it slow me down? Adrian, fantastic. It slows me down. So the trade-off of speed versus governance is if I add too many controls, we get slow. Anybody ever try to walk into a really high security environment where you go to the first place and then they check you and then they check your identification and then they stop you 5 minutes later and you go through another series of checks and then you go somewhere else and you go through another series of checks? It's not very fast. So the enterprise architect's challenge is going to be to build governance that enables speed rather than blocks. Okay. The next one we're going to talk about is standardization versus flexibility. If I standardize, I have very little complexity, right? Everything is the same. You go to McDonald's, you order your Big Mac, your fries, and a Coke, or whatever it is people order at a McDonald's. Standardization. Now, if I were to walk into a McDonald's and I were to say, I would like a half-pound hamburger with no bread that's cooked with 93% lean grass-fed beef, I would like it medium, cooked medium, with salt, pepper, oregano, and garlic put into the patty, and I would like a pound of broccoli associated with it, because that's how I eat, and then I'd eat some blueberries. Do you think I could walk into McDonald's and get that done? With the standards and the standards enforcement and the machinery they have and the recipes they have and the fact that everything's pre-made? No. So, and they would tell me to go to a restaurant, and I've tried, and they have, just to see if I could order broccoli at a McDonald's. Thought maybe they would have it for a health conscious individual when I was somewhere where there was nothing out there, but they didn't. So think about this. We use a single vendor's technology, whether it's best or not, serves our business best or not, or we can choose the best ERP system that meets our needs the best, the database that meets our needs the best, the compute platform that meets our needs the best. Which do you think is going to be better? So when would you use standardization versus flexibility? If we want increased speed and we want a cookie cutter design, what do we choose? Do we standardize it? The process, the machinery, the technologies to make it happen? Or do we buy different ovens, hire different people from different backgrounds, and let them do it their own way? Comment the answer to that in the chat box, because that's how we structure the business. It's not any different than the decision of stick everything in a single cloud provider or leverage Google for analytics, because your business would benefit most from Google's analytics. Leverage some of AWS's very large infrastructure, and then run a Nutanix cloud for your high throughput, high performance, high security environment. So standardize. It makes it cheap. Okay, so this next one's going to be, one of those kind of both business and technology trade-offs. Centralization versus decentralization. We could split our technology and our identity systems in a central location, or we could put them everywhere. We could try to take logs from all over the environment, or we can send them to a centralized SIEM and source system. We have a business that has 10 branches. We can choose to let those 10 branches make decisions on their own, or we can make those branches send a request to the central office where the big boss says you're allowed to do this, or no, you're not. Enterprise architecture trade-off, both business and technology. So centralization improves control, right? Got to send it to the big boss, and they got to give you a rubber stamp. It improves consistency because that centralized team is going to all think the same, typically have the same set of guidelines, and they're going to say yes or no consistently to the same thing. And guess what? Gives you an economy of scale. It only puts a few people in the decision-making process. All right. How efficient is it to send 50,000 requests to the same 30 people? Those 30 people are going to be rapid in responding to your requests. So in this one, I gave you for the business side of it, the trade-off. Centralize it, makes it very controlled, very consistent, very good economy of scale. Decentralization improves agility. That one I helped you. All right, let's talk about cost optimization versus performance. If I give you enough money, you can build anything. I can get you to any level of performance we want with enough money. Want a great AI thing and need 10,000 NVIDIA H200s? With enough money, we could buy it. We can fund an underwater data center. We can fund anything we want with enough money. Now, the question is, what performance makes sense? High performance costs more. Aggressive cost reduction will make it that no one wants to buy your product and it'll hurt customer experience. So what do you do? Depends on the business model. Some businesses are based on giving people a whole lot of things for a small amount of money, their own value. That's how we run our company. We give people a $30,000, $40,000 education for a couple days' pay. Because that's my goal in my retirement, is to train the next generation of architects. That's what we do. Other businesses run things very differently. Can't tell you what's right. But high performance comes with a cost. That's why a Lamborghini typically costs more than a regular car. High performance. But I really want you to think about that. So everybody tell me, what happens if you go to a website where you click on the website and 30 seconds later it doesn't load? How much time are you spending on that website? You go to click on something and there's a cold start latency because someone set it up, and the way they set it up, it takes a quarter of a second to even notice anything. Are you already bored and frustrated and already out the room and moved on to a new website because it was too slow? So what do? How much will you wait for something? So tell me what you would do in the chat box if you had to wait 30 seconds for your website to come up because somebody decided to economize on their website performance. Or right now, I am actually using an 8K camera. I'm not joking. And the 8K camera sits behind a 4K video encoder, and we're streaming it at 1080p. Would you care if I streamed it at 8K? Would it look any different for the most part in practicality over the internet stream? You probably don't. So the key is Adrian would go to a different website, D. Lassiter would leave the website. So that's what we have to think about with regards to cost and performance. Now, security versus user experience. I can make something very secure, but I can also make it miserable to lock you down. If I create a really strong security process, in order to go to our website, you need to log in. And then after you log in, you now have to do a multi-factor authentication challenge. Now, after you do the multi-factor authentication challenge, now you have to go to another system, and you're going to get a different kind of challenge. Now, after you do that, you access the system, and that grants you access to another system, but you're going to have to log in again and log in again, log in again. You're not coming back. You're not coming back. I once was in the airport in Athens, in Greece, and a friend of mine and I were taking a trip to somewhere else. We went through 4.5 hours of security checkpoints to go to the next place that we were going to. Everyone that was with me said, never going here again. I don't care what the purpose is. It's too hard and miserable to pay. So how many of you in the old days have worked for an organization that was so security obsessed that you had to log into your system 20 to 30 different times per day during the course of your job? I know I have. Now, While we're talking about trade-offs, what do most people do when they have 30 different usernames and passwords to use at work every different day? Did the 30 different passwords damage their user experience? Yeah. So what did they do? They started putting sticky notes on their desktop with their usernames and passwords to all their logins. And then there were books that used to say password book that people would literally have sitting on their desktop. Because what ultimately happened is we gave them such a bad user experience, we made it impossible for them to do their jobs that they created workarounds that made us less secure. And that's the key. So security versus user experience. If you make the experience too miserable, people will violate the security. So just keep thinking about that. Availability versus cost. Ooh, that's a big one. So in my life, I basically worked for three kinds of companies, and I've only worked for three companies in tech. I've either designed systems for hospitals, and if those systems go down, people can die. I've designed systems for banks where a minute of downtime is several $1 million of revenue loss. And I've designed systems for internet and TV providers where if the TV or internet goes down, they get hundreds of calls in a matter of 30 seconds of angry customers. These systems are built not to go down. What do you think it costs to build a true, drop it in the chat box, just say higher cost or low cost, to build a true mission critical 99.999% available system? And to give you an example of what that really takes, for the most part, it takes two cloud providers with two availability zones per cloud providers. In addition to that, it takes the right operational procedures, the right controls, the right change management structure, and that's minimum. And that's assuming that we don't have a significant outage that would affect two different cloud providers at the same time. The costs are going to go crazy. Exactly, Adrian. It's going to go crazy. Don't be shy. Drop some answers in the chat box, everyone. We want you to participate. We want you to become great enterprise architects. So think about that. Scalability versus simplicity. So I've only been there to design very big systems. It's just the nature of the work that I've been in. I just never had a junior level job, moved into more senior jobs pretty quickly. So every system that I designed was incredibly complex because it either dealt with, 2,000 low office locations, millions of clients. So they were huge. Now, what happens to an organization that doesn't have that sophistication? They don't know how to design the scalability. They're a startup. They designed something. They had one person that was a Linux engineer, that was the cloud engineer, that was the network engineer, that was the security engineer, and they put all this stuff together. They built for simplicity. They built it to work. Building for something that's going to grow to a few million users takes a very different architecture than something that's going to be there for a small business. Microservice is a perfect example. It may be the best architecture for a company like Google where they've got tens of thousands of developers or hundreds of thousands of developers, and they're all reusing each other's code platforms. Small business that tries to go down the microservices pathway will create such a level of complexity to create scalability they may never have that they may go bankrupt. So the key is we have to think about what's going to make sense. Here's another one: innovation versus scalability. I'll make it real for you. What's DevOps about? Being able to reduce software faster, make changes faster, add new features faster. And guess what? That's really cool if you've got a graphics editing program. And today they're going to teach you how to create new cat graphics. And next week they've got a new fancy section of cat ears for your cat graphics. That's wonderful. But what if you're designing a system that's going to power an airplane or a submarine or a nuclear power plant? Are we looking for innovation there? Or are we looking for stability? No fast DevOps release cycles. Make something, test the living daylights out of it, because if the software fails, people die. So this is where you don't adopt a platform early, or you don't introduce a new, cool cloud native service. All right. Now, we've gone through a few of these, so I want you all, there's a bunch of you out there, so give me some answers in the chat box. Build versus buy. What do you think we get, before I tell you, from building it, versus what do we typically get when we buy something from an architecture perspective? Give me some answers in the chat box. Hopefully somebody in addition to Adrian and Jason. Oh, Sarasso also. Get some more people. What do you think we get by building? We got to get some Jeopardy music for this, Chris, for the future. There you go. We're excellent, Ansling. We build it if it gives us a competitive advantage. When we buy it, we get something fast, right? It's quick. It's pretty easy to go to the store to buy whatever it is you want, but it gets you off the shelf. But if we build it, perfect, Andrew, we've got full control of the build. We can buy whatever we need to create differentiation for us. So absolutely, absolutely. Great job. Now, here's one for you. Let's say we want to use all this cloud native services by a single vendor, and we slap it together very quickly, all on a single cloud vendor. Now, by doing so, by using all these proprietary things, it gives us delivery speed, right? But what real problem does it become? What problem does it become when I'm all on this single vendor and another vendor has a much better solution for my business needs? And another vendor has a better product for forecasting for my business. And a different vendor has another option that will give me a competitive advantage in the sales process. Well, first, if I used a single provider and used all their native services, I have a single point of failure, which I don't want from an architecture perspective. But what else? It's technical debt and vendor lock-in. I use all this proprietary stuff. I'm handcuffed to whatever I bought. I can't get out. So that's technical debt when you make an architectural decision for the sake of speed, but it has major impact to your long-term agility and capability. Fast delivery, quick and dirty, often creates a whole lot of technical debt. Eliminating technical debt later means we can't do anything in the future until we resolve all the problems we have. So constantly as enterprise architects, we're maintaining technical debt. Here's one for you. Let's talk about the business itself. Let's say we've got a business and we have two options for the business. One option is we build for enterprise consistency. We replicate what we have everywhere. Think McDonald's. Wherever you go into a McDonald's, it's my understanding that you can get the same meal anywhere in the entire world. Cooked the same way, on the same machines, consistency. It's also my understanding that if you go to a Ritz-Carlton, and I've never had a bad experience in a Ritz-Carlton, but it's my understanding that if you walk into a Ritz-Carlton and you have a bad experience in some way, management has the autonomy to spend a lot of money to make you happy.
Not just management, every team member.
And Chris, because Chris is a hotel executive for many years, What kind of money can the average bellhop or front desk receptionist or whatever it is spend on a client to make them happy, Chris?
Uh, I think it was 2,000. I think. I've got my notes. Yeah, it's $2,000, but I think the average was about $100.
Right.
But
So the cost of that,
they were allowed to spend up to $2,000 to take care of any problem.
so think about that. You've got two opposite extremes. You've got McDonald's that optimize for consistency and for making sure everything stays that way. And then you've got the Ritz-Carlton where they're so concerned about making you satisfied, they can spend up to $2,000 any employee just to make you happy.
Yeah,
And
that's the story of the housekeeper that I was telling in one of our lessons in class. That a housekeeper literally bought an airline ticket to give somebody their laptop because they didn't trust the laptop was going to get there.
and that's the point. So look, I've spent a lot of time in hotels. Chris, you probably spent more time in hotels, but I've spent a lot of time in hotels. And I got to tell you, if you're traveling 365 days a year, you want to know you're going to be comfortable, you're going to pick a hotel that you know is comfortable. Now, at the same time, if your comfort zone is you like your Big Mac fries and a Coke, you're going to find comfort in the same stability that you can go anywhere in the world for the most part and get the same things, at least in the US. So those are two examples of consistency versus business unit autonomy. Autonomy improves each business unit and their ability to meet with local needs. Consistency improves governance, reduces cost. Reusability versus time to market. So if I create a platform that's meant to be reused or components of it designed to be reused, that's going to take a whole lot of planning. We're going to have to figure out what we need and what that structure is going to look like and how people are going to use it. That'd be perfect for someone like Chris, my chief operating officer, that could think of that kind of structure. The time to market person is, how do I get this done today? And the key is that the reusable platform is going to take a lot of time to get set up initially, where the point solution is going to be really fast. But long term, the reusability will probably give me faster time to market, except it may take a year or two to get to that point. Data accessibility versus data protection. If I make the data more accessible, everyone, put it in the chat box. Is the data going to be more secure or less secure if it's more accessible? Hope this one should be pretty easy. Let's see, this is the way our world is. It's every one of these knobs that we turn is going to improve something and make something more complicated. And that's why architecture is a balance, balancing trade-off. Exactly, Adrian, it's going to make it less secure. Because if I give broad access to data, I can make our analytics so smooth. Our AI is going to be simple and smooth. It's going to be beautiful. But, we've got a lot of access to the wrong places. And when something goes wrong, we're going to have a real problem. Resilience versus complexity. This changes a lot. If I don't need a lot of resilience, it's fairly easy to create an architecture. But if I need a lot of resilience, things get very complex. Now, let's have some fun with it. Let's have some fun with this one. So let's look at two different architectural examples. So here we go. This is the core of our network. And this will work in a moderate resiliency environment. Let's take the fill away from these. Give you an example for this one for fun. These are both routers. This is a link aggregation group containing 400 gig links. These two things over that I'm drawing over here are power supplies. Let's add the two power supplies to the next switch. Let's put two of these brains in here. They're called control modules that exist in these modular routers and switches, the super high availability ones. Here's two of them. This is plugged into a different power distribution unit and circuit breaker than this is, what have you. All in all, this is a relatively high availability solution, especially if we split these cables or these groups across two switches. Link aggregation group. So, meaning multiple. Now, if we have a server that plugs into this in a small business, we've got two very high availability switches and the server is plugged into both. This is fine. And this is going to be a very good high availability solution for a small business. It really will be. But what I want you to see here is if this server goes haywire, this server is now plugged into the core of the network. So if this server goes haywire and there's another server that's plugged in over here, this server could potentially hurt this. So, nobody's going to design that when they need a network that's going to meet, critical capabilities. So what organizations might do is let's say they call this the core of their network. And then they will have another series of switches. We'll call these the distribution layer. And if you look at what's going to happen, and I'll show you why we used to do this, and we still do this when it really matters, although we might do something slightly different for other if it's less critical. So let's try to create that. Let's try to create that. And then and this we'd call these distribution switches. And then what we would do is we'd have another set of switches. And then we would plug our servers into these switches and desktops. Well, different parts of the network. But by doing so, look what happens. If something goes haywire on this server, we can catch it at this switch. So we can contain it before it ever hits this layer and it never hits the core. But you can see what we're doing here is we're overbuilding to protect this part of the network. But we're only going to do that if it's a big environment where we need it. So that gets us to the reliance versus complexity. If it's simple, I could just plug everything into two switches and be done. But if I know I'm going to be going and I need high availability and I know I'm going to scale to 2,000 remote locations, then I need to protect every element of what I have. Let's talk about automation versus human control. Automation. I had some meal delivery from one of those food delivery apps. When it got here, the wrong food showed up. And when I went to call, there was nobody to call. I used the application and the application said, here's a $5 coupon for a future meal, but it was a food that I just can't eat. So the entire meal was wrong and I couldn't do anything about it because it was automated. Now, when you think about it, automation improves speed and it improves consistency. But without judgment, we don't have the ability to handle an exception. So we should automate things that we don't need a lot of control. And then we keep the humans in for elements that we do need control. Long-term decision-making versus short-term decision-making. Strategic architecture takes a whole lot of patience because we need to figure out what we have, where we're going, how we operate, how we want to operate. There's a lot to figure out. And then what happens when the sales team says, I need my sale application tomorrow or otherwise I can't sell. So long-term architecture versus short-term pressures. Global standards versus local requirements. Generally speaking, a company is going to build for things that work everywhere. But what happens when a country or a group of countries says, we don't want your product unless you change it? Well, either the company has an option to change the product, or they choose just not to do business in that certain part of the world. Quite simply that easy. So, the core reality of enterprise architecture is this: there's never a perfect opportunity. Never. Ever. Every architecture we create is about making an informed decision, a careful balancing act of the trade-offs: speed versus security, speed versus cost, everything all these dials that we're going to be turning. It's about balancing competing priorities, because sales needs it now. They need the product now. They need whatever it is now to go sell. The product team doesn't want to sell something that's not going to work. We enterprise architects are not about finding the prettiest technology. We're about finding the best business outcome. So if the best business outcome is going to come from using a mainframe, I'm going to invest in a mainframe. I don't care. I care what it's going to get me for the future. The best architectures reduced unintended consequences, where people don't know what's going to happen because you planned it out. And the best architectures are the one where the technology matches what the people need. So it's not about who's most technical. That's engineering. It's about being able to consistently evaluate, do we focus on this more, or do we focus on this more? Because we would like to go in both directions, but we can only go here. Which do we do? Understanding the business impact of the architecture we create, or the business impact of what we do. If our architecture is going to create $1 billion of business impact, chances are we can get it funded for $500 million. Just like any good doctor or consultant, you have to communicate trade-offs early. The same way a doctor says, we can treat this with some medication, or we can treat it with the surgery. If we use the medication, it will most likely work, but there's a possibility of a treatment failure. But the medication will be simple to take. It won't have any recovery time, and it won't affect your lifestyle. By comparison, we could do this surgery, but it's going to take 3 months to feel better, but it's going to be 100% sure that it's going to work. Trade-offs. This is a trade-off discipline, any kind of architecture advisory kind of thing. This is a job of influencing stakeholders. Because ultimately, we have a business. The business will have competing priorities, and it's our job to figure out what's in the best interest of the overall organization and get the stakeholders to adopt it. And then guide the organization to the best possible decisions under constraint. And that's really what we're here. So, I hope everybody had a good time learning so far with this Enterprise Architecture Fundamentals Bootcamp. I really hope so. I know I've had some fun. I've got to meet lots of wonderful people. I see you're all in all parts of the world. So I hope that was great. We have one more session coming next Wednesday, and we'll also be releasing a book with that session. So sign up now, and we'll email you that book when the book is available. My team will drop that in the chat box. I hope to see you at an architecture webinar, because it's live on Zoom, and I'd love to meet you. We'll talk about how to become an architect, the skills that you need, what we do, the kind of architect portfolio you should build, and everything else. It's free. So hope to see you join. My team will drop that in the chat box, as well as the description of this video. And then maybe give me a hashtag enterprise architecture. Give the video a like, subscribe to the channel, and send this video to a friend. We spend a lot of time, effort, and money putting these free boot camps together, and we want to help as many people as possible. So please share it with a friend. Thank you all for attending today's Enterprise Architecture Fundamentals Bootcamp. See you next week.